Hi guys, welcome back to our YouTube channel Tutorial Home by Electrical. You all know that WBSEDCL exam date is released and the exam date is very close. In this period, revision and attempting mock test is very important. I have already released a full mock test series. If you are interested, you can contact me. So let's start today's topic. In today's video, I will discuss some important formula about electrical machine. It is the video part 3. In part 1 and part 2, I have already discussed some formula about electrical machine. If you yet not watch that part, please watch that part from the given link in the I icon. So let's start today's topic. In today, I will start from induction motor. First, you have to remember the formula of electromagnetic torque. Electromagnetic torque T E equal to 3 by omega S into S V square R2 divided by R2 square plus S into X2 that whole square. Here omega S is synchronous speed in radian per second, S is slip, V is terminal voltage in rotor, R2 is rotor resistance and X2 is rotor inductance. Then you have to remember the formula of maximum torque. For maximum torque, R2 equal to S X2. For maximum torque, R2 equal to S into X2. S is slip, R2 is rotor resistance, X2 is rotor inductance. So the formula of maximum torque T E max is 3 by omega S into V square by 2 into X2. Here omega is synchronous speed in radian per second, V is terminal voltage in rotor and X2 is rotor inductance. Then you have to remember the formula of maximum slip. For maximum slip, Sn equal to R2 divided by X2. Then you have to remember the formula of rotor part vector. Rotor part vector cos phi r equal to R2 by Z2 equal to R2 divided by square root of R2 square plus X S into X2 that whole square. Here Z2 is rotor impedance, R2 is rotor resistance and X2 is rotor inductance. Cos phi r is phase angle between ER and IR. ER is rotor EMF, IR is rotor current. Cos phi r समान tan inverse S into X2 divided by R2. Then you have to remember the formula of ratio between the various torque. First you have to remember that formula between full load torque and maximum torque. TFL to Tmax. The formula of TFL versus Tmax is 2 into SFL SM divided by SFL square plus SM that square. Here SFL is full load slip, SM is maximum slip. There is another formula. The formula is IFL by Imax that whole square into SM by SFL. Here IFL is full load torque, full load current, Imax is maximum current, SM is maximum slip, SFL is full load slip. Then you have to remember the formula of ratio between starting torque and maximum torque. The formula is 2Sn divided by Sn square plus 1. Here Sm is maximum slip. Here one word you have to remember that in starting torque the SFL means full load slip equal to 1. There is another formula of ratio between starting torque and maximum torque. The formula is IST divided by Imax that whole square into Sm. Here IST is starting current. Then you have to remember the formula of the ratio between starting torque to full load torque. The formula is SFL square plus SM square divided by SM square plus 1 into SFL. There is another formula of ratio between starting torque and full load torque. The formula is IST divided by IFL, that whole square, into SFL. Here stator impedance and magnetic reactance are neglected. The above formula is applicable when stator impedance and the magnetic reactance are neglected. Then you have to remember the formula of step angle. Step angle or alpha equal to ns minus nr divided by ns into nr into 360 degree, or 360 degree divided by ms into nr. Here ms is phase per step and ns means stator teeth, nr means stator rotor teeth or rotor speed. This formula is actually for stepper motor, but here ns and nr is related, so I discuss this formula here. So come to the next formula. Here you have to remember the relation between synchronous speed and the step angle. Synchronous speed ns equal to alpha into f by 360 degree. Here ns is synchronous speed, f is frequency, alpha is step angle, and 360 degree. Then you have to remember some formula of starting torque in various type of starter. For DOL starter, means direct online starter, the formula is the ratio of starting torque to full load torque is IST divided by IFL, that whole square, into SFL. For start delta starter, the ratio of starting torque to full load torque is one third into IST by IFL, that whole square, into SFL. For the auto transformer, then you have to remember for the auto transformer starter. For the auto transformer starter, the ratio of starting torque to full load torque is x square into IST divided by IFL, that whole square, into SFL. Here S is transformer ratio. Then you have to remember the formula of developed mechanical power. Developed mechanical power PMD equal to PG minus PCU. PG minus PCU equal to PG minus S into PG. Here PG is gross power by rotor input, PD is mechanical power developed, PCU is rotor copper loss. So the ratio of PG to PCU to mechanical power developed, PG is to PCU is to PMD equal to 1 is to S is to 1 minus S. Here S is slip. Then you have to remember the formula of rotor copper loss. Rotor copper loss equal to S into rotor input. Then you have to remember the formula of approximate efficiency of rotor. The approximate efficiency of rotor is PMD by PG. PG is gross power, PMD is mechanical power developed. Then let's discuss some formula of single phase induction motor. Then let's discuss some formula about single phase induction motor. So in single phase induction motor, forward slip SF equal to S equal to NS minus NR divided by NS. Here NS is synchronous speed, NR is rotor. NS is synchronous speed, NR is rotor speed, and NS is synchronous speed. Backward slip equal to 2 minus S. And here Let's discuss some formula of synchronous machine. For synchronous machine, you have to remember the distribution factor. Distribution factor Kd equal to the division of phasor sum of coil voltage per phase to the arithmetic sum of coil voltage per phase, or distribution factor Kd equal to sin m beta by 2 divided by m into sin beta by 2. For harmonic, the distribution factor Kd equal to sin r into m beta by 2 divided by m into sin r beta by 2. Here r is the number of harmonic present and beta equal to 180 degree divided by number of slot per pole equal to 180 degree divided by n. Here n is number of slot per pole. Then you have to remember the formula of pitch factor. Pitch factor Kp equal to the division of phasor sum of coil side EMF to the arithmetic sum of coil side EMF. Also, Kp equal to cos alpha by 2. For harmonic, pitch factor Kp equal to cos r alpha by 2. Here r is number of harmonic present. Here alpha equal to the division of number of slot in short pitch divided by number of slot in pole pitch. Here pole pitch equal to total number of slot divided by total number of pole equal to full pitch. Pole pitch is also called full pitch. So here short pitch equal to full pitch minus coil pitch. Then you have to remember the formula of EMF equation per phase. EMF E equal to E max cos omega t minus 90 degree. E max is maximum generated EMF in synchronous machine. Also, E max equal to 2 pi f into n. Here phi is the flux, f is frequency and n is the speed. Also EM equal to 2.22 into phi into f into z phase volt. Here z phase is number of conductor per phase. Also EM equal to 4.44 phi f t phase. Here t phase is number of turn in per phase. Also EM equal to 4.44 Kp into Kd into phi into f into t phase. Here Kp is pitch factor, Kd is the distribution factor, and phi is flux and f is frequency and t is number of turn per phase. This above formula is also applicable for DC generator. And you have to remember some topic about V-curve and inverted V-curve. Here you have to see the figure of V-curve and inverted V-curve. In inverted V-curve, in the right side of this line, the generator or alternator works in PF lagging and motor or synchronous motor works in PF leading. And left side of this line, the generator works in PF leading and motor or synchronous motor works in PF lagging. And the culmination point of this is denoted by unity power factor. Then you have to see the figure of inverted V-curve. For inverted V-curve, the right side of this line, the generator or alternator works in PF lagging power factor and the motor or synchronous motor works in PF leading power factor. And left side of this line, the generator works in PF leading and the motor works in PF lagging. And this line is denoted by unity power factor. Then you have to remember the formula of power in alternator. In alternator, P or active power equal to EF into VA divided by XS into sin delta. Here delta is load angle, the angle between EF and V. Here EF is excitation voltage, and V is terminal voltage. And the formula of reactive power Q equal to VA by XX into EF cos delta minus VA. Here VA is terminal voltage and EF is excitation voltage and XS is synchronous inductance. Or active power P equal to E into VA by ZS cos theta minus delta minus VA squared by ZS into cos theta. Here theta is angle of synchronous impedance and ZS is synchronous impedance. E is excitation voltage, VA is terminal voltage. And Q or reactive power equal to E into VA divided by ZS into sin theta minus delta minus VA squared by ZS into cos theta. Here ZS is synchronous impedance and delta is load angle and theta is angle of synchronous impedance. It is generated by tan of XS by RA. Then you have to remember the characteristics of alternator and synchronous motor in various power factor. It is also applicable for DC generator or DC motor. In unity power factor, the alternator or DC generator work as purely cross magnetization, and the synchronous motor is also purely cross magnetization. Here CM is cross magnetization. In zero power factor lagging, the alternator work as purely DM. DM means demagnetization. And synchronous motor works in purely magnetization. In zero power factor leading, the alternator works in purely magnetization and synchronous motor works in purely demagnetization. And in 0.8 lagging, the armature of alternator works in partly demagnetization and partly cross magnetization. And armature of synchronous motor works in partly magnetization and partly cross magnetization. And in 0.8 leading, the armature of alternator works in partly magnetization and partly cross magnetization. And the armature of synchronous motor works in partly demagnetization and partly cross magnetization. Thank you. The end of the formula of electrical machine. In next part I will. So thank you. Thank you for watching this video. If you assume this video is helpful for you, then please like, share and subscribe with this video. And in next part I will discuss some formula about another subject. So bye till then and best of luck for your preparation. Thank you. Thank you again.